Hello guys, welcome to Staad Pro Tutorials. In this session we'll be discussing about the dynamic analysis of an RCC building using response spectra method. So let us take the building we took in the last session during the calculation of frequency of the building with eigenvalue extraction method. So as you can see, this is the building. Well, we will keep the same sizes, support. Coming to loads, we will remove all the load cases. Fine. Now response spectrum method first is carried out by defining the seismic definition. So let us go and define the seismic definitions. Select add. You select the code IS 1893-2002. Select generate. You can select as per zone wise or as per city wise, which may be Hyderabad. Select SMRF, general building, importance factor will be 1. Well, the soil will be medium soil. Damping ratio is 0.05%. Select generate. Now select add. Well, seismic definition is defined. Now we add self factor 1 for the definition, and floor weights will be dead load 4 in the range of 3 to 21 meters and 2 kN per meter square live load in the same range. After defining the loads, you can go to load case details. Select load case 1, select add, close. Select load case 1. Well, define the floor load, which is -4 kN per meter square in the range of 3 to 21 meters. Select add. And live load is -2 kN per meter square in the range of 3 to 21 meters. Once you are done with the dead and live load, you can add another load case, which will be response spectrum load case. So in order to define the response spectrum, we need to specify few parameters. First will be the self weight, and coming to response spectrum, the load should be same in all the directions. So providing self weight with factor 1 in all the 3 directions. Then providing floor load of dead load 4 kN per meter square in the range of 3 to 21 meters in all the 3 directions. Next will be live load 2 kN per meter square in all the 3 directions. Now that you are done with loads, close it. Assign the self weight to the view or structure. Well, you are done with the assigning the loads. Then we need to assign a response spectrum command. Select load case, add response spectra, select code as IS 1893. Combination method will be SRSS, subsoil class will be medium, and damping ratio will be 0.05. Direction will be 0.036. This is calculated by the formula Z by 2 into I by R. So Z is 0.36 by 2 into I is importance factor, which is 1, and R is reduction factor, which is 5. So 0.36 by 10 gives 0.036. You can even add torsion box, select add plus. Now going to analysis and print, select mode shapes, select add. In post print tab, you define commands, analysis and results, and story drift, add close. Story drift may or may not be added. Now analyze the structure. The design was carried out in the previous problem, however, we just modified the loads. Even if you have not seen the figure or the problem in the previous session, you can just draw a building and assign the properties to it and the supports. Then you can continue with the loads and definitions. There is no need for designing anyhow. Once we are done with analysis, we can go to output, in output file. First you can see this is the note: base shear from the response spectrum is less than the base shear calculated using empirical formula for fundamental time period. So since VB is less than capital VB is less than small VB, as per IS code 1893, what we do is we multiply this multiplying factor with all the response quantities. Well, on multiplying this 2.4858, so you can see .4858 is multiplied with 0.036 that we have calculated by the formula Z by 2 into I by R. So we got 0.0894. This will be replaced by 0.036. However, let us see the other specifications. Well, let us go to results. First you can see eigenvalues, 6 mode shapes are provided, and the frequencies are also given for those. Well, here are the modal masses in 3 directions, X, Y and Z directions, and this is dynamic weight of the building, this is the missing weight of the building. Dynamic weight minus missing weight gives modal weight of the building. Coming to mass participation factors, You can see in the first mode there is a 80.46 participation factor in Z direction. Similarly in X direction in the second mode, and the total shear is obtained to be 86.57 as per CSM method. You can see the time period too. However, if we replace all the response quantities with we need to replace the 0.036 with 0.0894. So let us go to loads, select the response spectrum, select edit. This is replaced by 0.0894. Select change. Now analyze once again the whole structure. Well, you need to close the output file in order to run the analysis. Now you can see that the base shear will not exist. The base shear VB will not exist the shear small VB. Go to output file. Well, now you can see that the multiplying factor is equals to 1. It's fine. Now go to results. You can see the I mode values provided here. And the participation factors are also given. So in this way the dynamic analysis is carried out. If you go to post processing, you can observe the dynamics of the structure for mode 1. You can select the second mode here. Similarly third mode, which is torsional, fourth mode, sixth mode. Even you can animate by selecting mode, giving frames, target speed, and selecting scale, decreasing. Then selecting apply. Let's see, you can see how it is. Well, you can see for the others also. In this way, the dynamic analysis of an RCC building is carried out using response spectrum method. This is the end of the session. For more videos, please subscribe. Thank you.